Hi guys, from this tutorial we are going back to algorithms. We have in data structure we have discussed linked list and arrays, and there are some more data structures which we should discuss, but before discussing them there are some basic algorithms which we should discuss first. Okay, so we will go to stacks, queues, trees and graphs later when we are done with these basic algorithms. So since we know that algorithms are basically some set of steps to solve a problem, okay, that's not hardware dependent or not program dependent. That's the idea which can be implemented in any language. So that's the algorithm. So there are some problems for which algorithms are, I mean the solutions are already there. So that's what we want to understand here. So first such problem is searching. And what is the problem statement? I mean, what is basically this problem is given an array, given a list, basically that list can be anything, linked list or an array, anything. So given a list and an element x, find x in list if it is present. So if x is in list, return its position, else show some error message. Okay, so this is the linear search problem. Now we this is not the linear search problem, this is the search problem, and there are solutions. There are basically two types of solutions. First one is linear search and second one is binary search. So we can apply these two algorithms to solve the problem of searching based on how the input is given to us. So first let us understand what is linear search. Okay, so given a list, say in the form of array, say we have int a5 which contains these 5 elements in it: a0, a1, a2, a3 and a4. These are 5 elements. Say these are 10, 20, 30, 40 and 50. So these 5 elements are there, and a is the pointer, or say a is the name of the array which is containing these 5 elements. Okay, now what? Now we are given another element, say x, which is equals to 40. Now the problem is to find this x in your array a. Okay, so to find that, what you need to do, you need to take that x. So you have your x here, and what you will do, you will take first these two, you will compare. If this is equals to this, you will return that okay, I got the element, this element is equals to this element, and then you just return this 0. If this is not true, if these are not equal, then go to these two. If these two are equal, then do what? Then return the position. If this is also false, then go to this third element, and so on till the last element in the array. Compare. If it's equal, if it equals, then you return the position. Otherwise, in the end of the array, if you didn't find any index which is having the element equals to this element, then what you will be saying, that there is no such element in the array. In such a case, you will return false, or you will return -1 in the programming terms. So how will you implement a linear search? Linear search, this is a function which needs, say, an array int a or a pointer to this array. Okay, because you don't call a function with the whole array, you just point the pointer to the array the address of the array, that means the address of this a actually is a pointer which contains the first element, say 1000, and this is 1004, 1006, 1008 and so on. So this is actually this 1000. Okay, so what is linear search here? Linear search will have its own, say, counter or say I, and what you will do, you have that x, right? You are given that x and I am supposed to find 40 here. So to find that x, you can scanf it, it doesn't matter, you can have it in any way. So once you have your x and your array, and you just provide the values, I am not doing that here, I am just showing you the logic. So what you will do, you will have a loop, the size of this array is 5, and increment the counter, and what you will do, you will have a condition. What condition? Since you are comparing with each element, so just take that x and compare it with all the elements. If anywhere this x is equal to this ai, that element within that array, what you do, return, say return the position which is I here, right? So you want to return the position I. Otherwise, if it never returned in this loop, it means that that element is not in the array, right? So in that case, return -1, that this is a message to the compiler that okay, the logic is failed. There is, or in this case, it says that the element is not in this array. So this is how you implement the linear search. Okay, so linear search, you got the idea, right? In any case, whether your element is in between or in the end of the linked list, in the end of the list, in any case you have to start from this node and you should go to that node until you find that element in between or somewhere in the position in the array. Okay, so this was the first way to solve the problem of searching. So you know that in the worst case, you have to either you find your element here or that element is not actually in the list. So in such a case, okay, I guess I never explained you what is worst case, what is best case, and what is average case complexity. So I'll show that also here. So basically there are complexity classes, or say complexity. There are three kind of complexities. Let's start from the positive one, that is the best case complexity, and there is an average case complexity, and there is a worst case complexity. Okay, these three types of complexity classes are there. So why these three different classes? Best case is when you have your element x and you start from the first position in this array. You have it, you compared, you got compared, you got these two elements compared and you got a true. It means this element is equals to this element. Suppose this is 10 and this is equals to this. So it's a success. So best case is that element is in linear in a problem of searching for linear search algorithm, you found an element at the beginning of the array, and since you are always starting from the beginning of the array and that's independent of the size of the whole array, this is the constant time, right? So you are always coming to the first position of the array and you are comparing that element x with this element, the first element, you are getting compared and you are getting the true result. So this is theta1 for the case of linear search. So best case means that what is the complexity of an algorithm, the minimum complexity. What is the best case that this algorithm can perform? So that's basically in the case of linear search, this is the best case this algorithm can do, right? And what is the worst that this algorithm can do? That you are comparing, or in the end of the array you are finding that that element, either that element is not in this array, or that the last element is the element which is we are looking for. So that's the worst case. This is the worst that this algorithm can do. And if your element is somewhere in between, say if you find that element here, then you actually anyhow went through half of the list, half of the array. Even in that case, you are searching n by 2 or n by 4 or n by 6 of the array, because this is involving n, this is anyhow theta n. Okay, so best this algorithm can do is theta 1. The worst this algorithm can do is searching the whole array, that's theta n, and the average case is that it's going to some way, half or 1/3 or 1/4 of this array. So these are the three different classes and complexity notations for linear search algorithm. Okay, okay, that's quite enough for linear search.